For our network roller shutters, only one little charger is used to charge the batteries to run up to 10 shutters. This is the key of achieving the world's lowest standby power. Let's look at the standby mode. In our network roller shutters, the standby mode allows us to run the internal sensor and the timer, and also start the remote control. The government estimates that Australians spend $950 million on standby power consumption, producing 6.5 million tons of carbon dioxide. For this reason, each country is eager to reduce this standby power. Now, shall we see what's the standby power of each product? In 2005, the government data showed the average standby power used by each product. The lowest was 0.4 watt. Now, let's see how each country in the world plans to reduce its standby power. The EU has changed its regulation to reduce standby power to 0.5 watt from January 2013. What would you think if standby power of one shutter was 0.07 watt? Isn't this a great innovation? Network roller shutters have achieved this goal. Here we measure the power twice to reliably determine the standby power used. The power pack shown is supplying 10 shutters and 10 sensors on standby. The working voltage is 246 volts, and the power rating is 0.7 watt. Hence, the standby power for each roller shutter is only 0.07 watt. Now we measure again, this time with the right-hand device. Both measurements show the 10 roller shutters and 10 sensors consume 0.7 watt on standby. This must be a reliable measurement. This time, it shows the standby power when TFT LCD master controller is also attached to all 10 roller shutter and 10 sensors. You can detect that the TFT LCD master controller consumes a standby power of 0.2 watt. If you visit our demo house, you can see the world's lowest standby power devices. Network roller shutters not only use the lowest standby power, but we also can charge our batteries overnight during off-peak time from 10 p.m. to 6 a.m. If more people change to off-peak times, the peak power needed during the day would be less, and so we would not need to build expensive additional power stations and power infrastructure. We do not yet know if we can claim the cheaper off-peak rate for our nighttime usage by network roller shutters. Shall we see how this technology works? Network roller shutters have a timer in the TFT LCD master controller. At 10 p.m., it starts charging the batteries sequentially from shutter 1 to shutter 10. The charge taken from the batteries, as the shutters work during the day, is completely replaced during the night. This is the same as hot water systems use off-peak power. Can we check if the battery for a roller shutter is charging? When the shutter 1 battery is charging, a red LED light on the shutter 1 controller will light up. Can we check what time this charging will start? The TFT LCD screen shows it is after 10 p.m. It also shows that shutter 1 is charging from the glowing icon. Only network roller shutters can do this.